In this problem, we have two trains, train A and B, and they're traveling on two different tracks. Okay, so we have two different tracks. Let's set that up. Here's train A on the blue track. That's train A, I'll label that. And then train B we'll put on a green track. So they're on two different tracks. And I think it says, yes, they run parallel to each other at constant speeds. So these tracks, they're parallel, which is good, right? They don't have to cross each other. We don't have to deal with any of that. Train A is 300 meters long, and train B is 700 meters long. So train A, let's sketch train A out. That'll be my train A. That is 300 meters long, and train B is 700. Now, one thing I didn't write in this problem, but was a given, is that when train A is behind train B, we can line them up just like this, where the front of train A is precisely at the back of train B. So that's important. Now, when they're going in the same direction, we know it takes train A 30 seconds to pass train B. So to pass train B, and we're also given this in the problem, although I didn't write it here, the back of train A will be right at the front of train B. So train A will move up here, and it's still 300 meters long, right? And when they line up, the back of train A is right with the front of train B. So when train A passes train B like this, right, they're both going in the same direction in this case. They're both going to the right. When they're both going that way, it takes train A 30 seconds to pass train B. And then when they're going in opposite directions, so when maybe B is going to the right and A is going to the left, it takes train A 20 seconds to pass train B, which makes sense. If the trains are moving in opposite directions, right, they're moving against each other, so they'll pass each other even faster. How fast is each train moving in meters per second? So isn't it great that we can actually figure this out? And let's look at this. My approach to this is based on the idea that distance equals rate times time. So when we don't know a distance, we can just say, we can think of that distance as a rate times a time, and we don't know a time, we can think of it in terms of rate and distance and so forth. I'm going to write rate as a velocity, right? And we're going to say, and that's going to be represented with V. And we have two trains, train A and train B. So in the first scenario, train A has to pass train B. And what that means is if we think of this point right here at the back of train A, this point has to go all the way up here, right? I'm going to think of one point on train A because every point is going to move the same distance. So pick one and think about that. When this point moves, it moves 300 meters and 700 more. So when train A is passing train B, and they're moving in the same direction, the distance that is being traveled is 1,000 meters. So that's distance, right? 1,000 meters. And that equals, well, it happens in 30 seconds. So I'm going to write 30. I'm just going to write 30. I'm not going to write seconds because my S's will look like 5s. And what's our rate? Well, it's tempting to think of the rate as 1,000 divided by 30 seconds. But think about the fact that A and B they're both moving in the same direction, so their velocity is relative to each other. So the velocity of A, right, we have to think about it in terms of what B is moving as well. So we have to take away the velocity of B. Because A is passing B, it's moving faster than B, but it's also moving relative to whatever speed B is moving. And you can think of that as B moving with it, right? So it's B is moving along with it. Take that velocity away. And if we solve this, we can divide both sides by 30 seconds, and we are able to say that whatever the velocity of these trains are, the velocity of A minus the velocity of B is going to equal 1,000 meters divided by 30, which is just 33 and a third meters per second. I'm going to try to write meters per second in here. Meters per second. And that makes sense, right? We're just dividing this out. Meters to the amount of seconds, so this is 33 and a third meters per second. And then what happens when we have the trains moving in opposite directions? In this case, let's say train A is going to the right, we don't know, that doesn't really matter, but we know they're moving in opposite directions. And train B is moving to the left. Since they're moving in opposite directions, right, the velocities aren't changing, but their relative velocities are. They're moving in opposite directions, so they're going to pass each other even faster. One thing that's not going to change, though, is how much distance is actually being covered. To get, for these points to actually cross, for the back of train A to get to the front of train B, or vice versa, I guess in this case the back of train A to reach now, which is the back of train B, that still has to be 1,000 meters, right? To travel 300 and 700 more. So now we have 1,000 meters equals, well, this time the velocities, we're going to add them. And I think that makes sense if you just step back and think about that. The two velocities are moving in opposite directions, so we add them to each other because it's almost like they're increasing the speed in a way, right? B and A are moving relative to each other, and their speeds are compounding and adding on to each other. And this is happening over 20 seconds. So when we divide both sides by 20 here, we're able to figure out that 1,000 divided by 20, well, what's that? That's 50, right? 50 meters per second. And that equals the velocity of A plus B. So VA plus VB equals 50 meters per second. So now we have everything we need to figure out precisely how fast each train is moving in meters per second, because we have these two equations and we have two variables. So we can solve that. We can deal with that. Here's how I might do that. Let me just erase some of this. Okay, so what do we have? Well, let's start with VA minus VB. Right? V of A minus V of B equals 33 1/3. I'm going to leave at the meters per second for a little bit because I don't want to actually confuse myself or confuse you with my handwriting. And then the other equation we have is VA plus VB equals 50 seconds. So let's rewrite that one as VA, going to subtract VB on both sides. So VA equals 50 minus VB. And we can just plug this, right, into here. Because V of A equals 50 minus VB. So now we have this equation, going to rewrite it. Same thing, just substituting the values in. So we have 50 minus VB minus VB, right? We're subtracting, here we're just substituting 50 minus VB for this term, and then we're subtracting VB from that, equals 33 1/3. Okay, so now we have 50 minus VB minus VB. What is 50 minus VB minus VB? Well, you can think of that as -1 minus 1, which is minus 2 VB. So we have 50 minus 2 VB equals 33 1/3. So now actually what I'm going to do is I'm going to subtract 50 from both sides. And what will that give me? Let's write that up here. What will I get if I subtract 50 from both sides? Well, if I subtract 33 1/3, well, if I subtract 50 from 33 1/3, right, I'll still have the minus 2 VB, but that's just going to be equal to negative 16 2/3. And now I want to divide both sides by -2. That'll give me a positive value. So what's negative 16 2/3 divided by -2? Well, it's positive 8 1/3. So the velocity of train B is 8 1/3 meters per second. Meters per second. And we're almost there. Now we want to figure out, well, what is VA? Isn't that right here? VA is just 50 minus VB. So VA equals 50 minus 8 1/3. So what is 50 minus 8 1/3? Well, 50 minus 8, that's 42. And then minus another third is 41 2/3 meters per second. And this actually does make sense, right? Velocity of train A should be greater than the velocity of train B because A is passing B. So in order for A to actually pass B, it has to have a higher velocity. And I'm just going to double check my math because I've been making mistakes on this video. and my students have been catching it, which is actually kind of exciting. But anyway, so one more time. Velocity of A is 50 minus the velocity of B, right? So 50 minus 8, yes, that's 42, minus another third is 41 2/3. Okay, I think I finally have gotten this problem correct.